Hello friends, I am here with the class 10 topic quadratic equations chapter number 4. In this video I will discuss about exercise 4.4 question number 1 and 2. So let's start with the question number 1. Find the nature of the roots of the following quadratic equation. If the real roots exist, find them. So first part is 2x square minus 3x plus 5 is equal to 0. So in solution part, given equation is 2x square minus 3x plus 5 is equal to 0. We will compare it with the standard quadratic equation, that is ax square plus bx plus c is equal to 0. And we will equate these two equations. So after equating, we have a is 2, the value of b is minus 3 and c is 5. Now discriminant is b square minus 4ac. So minus 3 whole square minus 4 into 2 into 5. So after solving it is coming minus 31. So your discriminant is coming minus 31, that is less than 0. So we have discussed the nature of the roots. When discriminant is less than 0, then we will say it has no real roots. There are three nature of the roots. When discriminant is greater than 0, then different real roots. When discriminant is equal to 0, same real roots. And when discriminant is less than 0, then it has no real roots. So here in this question, discriminant is coming negative, so it has the no real roots. Then we will not find the roots here. The second part is 3x square minus 4 and root 3x plus 4 is equal to 0. In solution part, given equation is 3x square minus 4 and root 3x plus 4 is equal to 0. We will compare this equation with the standard quadratic equation, that is ax square plus bx plus c. So after equating, we have a is 3, b is minus 4 and root 3 and c is 4. So now discriminant b square minus 4ac, that is minus 4 and root 3 whole square minus 4ac. So we will solve it in the rough part here, minus 4 and root 3, minus 4 and root 3 into minus 4 and root 3. So minus minus becomes a plus, 4 4 is a 16, and root 3 into under root 3 becomes 3. So 16 3 is 48, and 4ac, that is also the 48. So 48 minus 48 is coming 0. So discriminant is coming 0. Therefore, we can say that it has the two real and equal roots. It has two real equal roots. So by quadratic formula, we have x is equal to minus b plus minus square root of b square minus 4ac upon 2a, and b square minus 4ac is discriminant, already we have calculated here. Now substitute the values of b and a, minus sign as it is. The value of b is minus of 4 and root 3 plus minus square root of discriminant, its value is 0 upon 2a. So minus minus becomes a plus, it becomes 4 and root 3, 2 3 is a 6, plus minus square root of 0. So square root of 0 is 0. So when we'll add 0 or minus 0, the value will remain same. So now it is 4 and root 3 upon 6, and we can cancel it by 2. 2 2 is a 4, 2 3 is a 6. So my roots are 2 and root 3 upon 3. And we can write it like this way, 2 and root 3. This denominator part I can write under root 3 into under root 3. So this under root 3 and under root 3 will cancel out. So we can write answers like this way, 2 upon under root 3 and 2 upon under root 3. So next part is 2x square minus 6x plus 3. In solution part, given equation is 2x square minus 6x plus 3. Compare it with the standard quadratic equation. So we are getting the values of a, b, c here. A is 2, b is minus 6 and c is 3. Now discriminant is b square minus 4ac. That is minus 6 whole square minus 4a into c. So 36 minus 24 is coming 12, that is greater than 0. So now discriminant is coming greater than 0. So it means it has two different real roots. So by quadratic formula, we have x is equal to minus b plus minus square root of b square minus 4ac upon 2a. So x equal to, the value of b is here minus 6. I've substituted here plus minus. The discriminant, its value is coming 12 upon 2a. So minus minus becomes plus, 6 plus minus square root of 12 upon 4. Now you see in the numerator part, we can write it 6 plus 12. I can write here, the factorization of 12 is 2 into 6, 2 into 3. So factorization of 12 is coming 2 into 2 into 3. So pair of 2 is completed. So I can write it's 2 and root 3. So in the next part, you see in the numerator part 2 is common. So I have taken 2 common. So it is left here 2 inside the bracket, 3 plus minus and root 3. And 4 I can write 2 into 2. So this 2 and 2 will cancel out. So answer will be the x is equal to 3 plus minus square root of root 3 upon 2. So we can write it as x is equal to one time with the positive sign and one time with the negative sign. So these are the two different roots are coming here. Now come to question number 2. Question is here, find the value of k for each of the following quadratic equations so that they have equal roots. So this question has a two parts. First part is 2x square plus kx plus 3 is equal to 0, and second part is kx into x minus 2 plus 6 is equal to 0. So let's take the first part. Given equation is 2x square plus kx plus 3 is equal to 0. Compare it with the standard quadratic equation ax square plus bx plus c. So after comparing, we have value of a is 2, b is k, and c is 3. So it is given that question is find the value of k for each of the following quadratic equation so that they have equal roots. Now it is given in question, given quadratic equation has the equal roots. So when given quadratic equation has equal roots, when the discriminant is equal to 0. So I'm writing here given equation have the two equal roots. Therefore d is equal to discriminant is equal to 0. So b square minus 4ac is equal to 0. Now substitute the values. K square minus 4 into a is 2, c is 3. So it becomes k square minus 24 is equal to 0. K square equal to 24. Now I'm taking square root on both sides. So this square and square root will cancel. K is equal to plus minus square root of 24. Now the prime factorization of 24 is here 2 into 2 into 2 into 3. So pair of 2 is completed. So I can write here 2 under root 6. So plus minus 2 under root 6 is the value of k here. Now the second part is kx into x minus 2 plus 6 is equal to 0. Now you see it is not looking like a quadratic equation, and there is a one bracket, so we have to multiply it. Kx into x becomes kx square minus 2kx plus 6 is equal to 0. Comparing this equation with the standard quadratic equation, that is ax square plus bx plus c is equal to 0. After equating, we'll see the value of a is k, b is minus 2k, and c is coming 6. So it is given that this equation has the two equal roots, therefore discriminant is equal to 0. B square minus 4ac is equal to 0. The value of b is minus 2k minus 4a into c. So it becomes 4k square minus 24k is equal to 0. Now it is a quadratic equation, and now constant term is missing here. So what we'll do, we will take the common from the first two terms. So when we've taken the common from the first two terms, its common is 4k. So it is coming 4k into k minus 6 is equal to 0. Now the product of two terms is equal to 0. It means either first term is equal to 0 or second term is equal to 0. So from here it is coming k is equal to 0 upon 4, that is 0. And it is k is equal to 6. My k minus 6 is equal to 0. So the value of k is coming 6. But my answer is this, k is equal to 6. K is equal to 0 is not possible here. Why it is not possible? Because when I will substitute the value of k in the given equation, the value of k is 0. So 0 into this whole thing becomes 0. And 0 plus 6 is equal to 0. So 0 plus 6 is 6. And 6 is equal to 0, that is not possible. Therefore the value of k is equal to 0 is not possible here. Again I'm saying, when I will substitute the value of k is equal to 0 in the given equation, so this term is multiplied here. 0 into this whole thing becomes 0. So 0 plus 6 becomes 6. 6 plus 6 is equal to 0. That is not possible. Therefore the value of k is not possible here. So answer is here k is equal to 6 is the right answer. That's all.